We can compare two fractions as long as they have common denominators. If there's different denominators, it's very hard to know which one is larger or smaller. There are some cases when it's quite easy, but when it's ambiguous, like it is in this case, 4/5 and 6/7, the best thing you can do is use a common denominator, which you can find using the least common multiple. So 5 and 7, the least common multiple of 5 and 7 is, or you just list out multiples for 5. It's going to be 5, 10, 15, 20, 25, and 30, 35. I will stop there because 7, 14, 21, 28, and 35. I know 35 is the least common multiple. That just comes from the fact that 5 times 7 is 35. It's also the smallest multiple. So I'm going to use the least common multiple for this. And the way I'm going to do that is I'm going to take 5 times 7 is 35. So 4/5 times 7 over 7 should get an equivalent fraction. It's going to be 28 over 35. So 4/5 is the same thing as 28 over 35. And 6/7, right? 7 times 5 is 35. So I multiply this by 5 over 5. 6 over 7 is the same thing as 30 over 35. And I can easily see here between these two things, which one's larger? Well, 30 over 35 is larger. So 6/7 is greater than 4/5. Very easy to see when you have a common denominator. Okay, so for each pair, we're going to use less than, greater than, or equal to compare the two fractions. And to do this, let's just use a common denominator, which is going to be the least common multiple. 7 and 3, these are both prime numbers. The only way they can have a common multiple is just taking 7 times 3. That's going to be the least common multiple in this case. You can list out the multiples of 7 and 3 if you'd like, but 7 times 3 is a common multiple. So multiplying top and bottom by 3, I'm going to get 9 over 21. And multiplying top and bottom by 7, I'm going to get 7 over 21. 9 over 21 is greater than 7 over 21, so 3 over 7 is greater than 1/3. 5 and 2, once again, these are both prime numbers, so 5 times 2 is going to be a common multiple. 5 times 2 is 10. 3 times 2 is 6. These are the same fraction. 1/2, I'm going to multiply top and bottom by 5. 2 times 5 is 10. 1 times 5 is 5. 6/10 is greater than 5/10. Okay, again, 13 and 7, these are both prime numbers, so I'm going to multiply them together. 13 times 7, 11 times 7 is just 77. 13 times 7 is going to be 10 times 7 is 70. 3 times 7 is 21. That's going to be 91. Multiply this on top and bottom by 13. We're going to get 91. 6 times 13 is going to be 6 times 10. This is 60. 6 times 3 is 18. 60 and 18 is 78. 78 is larger than 77. And 6/7 is greater than 11/13. Okay, the common multiple here, well, 4 times 2 is 8. So 8 is the least common multiple. So 3 times 2 is 6. 4 times 2 is 8. Of course, this one stays the same. And these are equal fractions. 3 times 3 is 9. So 9 is the least common multiple between those two things. 2 times 3 is 6. This one stays the same as 5/9. And 6/9 is greater than 5/9. So 2/3 is greater than 5/9. And finally here we have 45 and 27. Neither of these are prime. And for this one, I can actually see that 27 is going to end up being 3 times 3 times 3. 45 is 3 times 5. So I know I'm going to have, I need 3 3s and a 5. So the least common multiple is going to be 3 times 3 times 3 times 5. Just wanted to show you that method again. But what you can do is you can just list out the multiples of 27 and 45, right? 27, use a calculator for this, 27 times 1, 27 times 2, 54. Let's use a calculator for this just to make sure I'm not miscalculating. 27 times 3 is 81. Times 4 is 108. Times 5 is 135. Let's look at 45. 45 times 1 is 45. Times 2 is 90. Times 3 is 135. And that really becomes from the fact that this thing needs to be multiplied by 3. This one needs to be multiplied by 5. And that gives me the same thing in both. Okay, so I know that I need to go 45 times 3 and 27 times 5 to get the least common multiple. Let's do that. 45 times 3 is 135. 10 times 3 is 30. 6 27ths, if you multiply this bottom by 5, you get 135. And 6 times 5 is 30. So these are actually equal to each other. A good way of checking that is to actually reduce the fractions down. That actually made this whole process a whole lot easier. 10 over 45, I can divide top and bottom by 5. I get 2 over 9. And 6 over 27, I can divide top and bottom by 3 to get 2 over 9. And right there, I could tell these two things are equal. So not always do you need to build up the fraction like I've done in pretty much all of these. Sometimes if you can reduce the fractions down, you should always do that because it makes the numbers easier to work with. Smaller numbers are always easier to work with. Okay, let's show how to graph some fractions. A good way of doing that is to split it up into sixths, and then also I have eighths here. Fourth is going to be an eighth as well. So if I just split it into eighths, I can take care of that as well. So eighths is going to be cut in half, half again, and then half one more time. Those are going to be eighths. So again, half, half again, and then half one more time. And then sixths, let me do that in red here. I'm going to look again at the whole thing. If I cut it in half, and then cut the remaining half into thirds. So kind of ignore what's there and just cut it into thirds. It's going to be about here and here. So I'd say about here, and it's not going to be quite on that one. I drew it a little incorrectly there. The same thing is true here. I'm going to draw a line and then say cut it into thirds. It's going to be about here and here. That looks to be about equal thirds. So it's going to be about there and there. Okay, same process here. Okay. So 0 6, this one's quite easy. 0 6, 0 divided by 6 is just 0. So this right here is 0 6. 2 6, that's the same thing as 1/3. 1/3 of the way up to 1 is going to be, well, there's 1 6, there's 2 6. This is the same thing as 1/3. Or 1/3. 5 6, right? We have 1 2 3 4 5 out of the total 6 that are there. 6 6 is the same thing as 1. 9 6, well, here 6 6, 7 8, 9 6, which is the same thing as 2/3, right? So this is 1/3. This is 1. This is the same thing as, sorry, 3 halves. Gonna go up 1 and then up a half. This is the halfway mark between 1 and 2. Okay, 1/8, that was in the blacks. The black lines are 1/8 marks. So this is gonna be 1/8. 8/8 is the same thing as 1, so this is the same thing as 8/8. 11/8, this actually can't be reduced at all. This is 8/8, 9/8, 10/8. This is going to be 11/8 here. 0/8 is the same thing as 0/6. 0/8. This is just 0, along with this one. And finally, 3/4. 3/4 is going to be, here's 1/2. 3/4 is going to be 1/4, 1/2. 3/4 is right here. 3/4 is the same thing as 6/8. So we have 1, 2, 3, 4. That was also the same thing as an eighth. 5, 6. 6/8 is the same thing as 3/4. So of course you can just draw a dot to show that that's what we're talking about here. This was 2/6. This was 3/4. 5, 6, 1. But I just labeled where they're at on the real number line. That's how you can kind of see, portion them out to see the parts of the whole numbers the way I've shown here. Let's talk about a little bit more different cases, the unusual cases of numbers, of fractions. 4/1 is the same thing as 4 divided by 1. 83 divided by 1. 254 divided by 1. And whenever you divide by 1, you just get the number 4, 83, and 254. Nothing's changed there. You're just dividing it by 1. 1 can go into 4 times. 1 can go into 83 times. Here we have 4 divided by 4, 83 divided by 4, 83 divided by 83, and 254 divided by 254. In each one of these cases, you get just 1. 4 can go into 4 one time. 83 can go into 83 one time. Here we have 0 divided by a number, and 0 divided by a number, as long as it's not 0, is always equal to 0. Alternatively, if we have a number divided by 0, this is not allowed in mathematics. You cannot divide by 0. It creates a lot of issues. It gives you a lot of incorrect answers. This is undefined. That's the way we label that in mathematics. Okay, to simplify each of these if possible. 5/1, this is just 5. 6 can go into 6 once. 0 divided by anything is just 0. 1 divided by 6, well, this is actually simplified. There's no other way of writing that. Well, you can write it in infinitely many ways, but this is the simplest form of this fraction. 1 divided by 1 is 1, and anything divided by 0 is undefined.